Okay. So most recently, we've talked about how to calculate speed and how to graph speed. And we also started talking about acceleration and also how to calculate acceleration. But let's rewind a little bit and let's talk about how to calculate speed. So, speed is simply calculated as distance divided by time. And you could use a car speedometer to remember this. Uh, in the United States, speedometers are in miles per hour. Miles is a unit of distance, and hour is a unit of time. They say per, miles per hour. Per means that you divide them. So miles divided by hours. Distance divided by time. And that is the formula for calculating speed. It is just distance over time. But in the world of science, we use SI units. SI units are the internationally accepted units for expressing measurements. All right? And the unit for distance, the SI unit for distance is meter, and the SI unit for time would be seconds. So speed, the SI unit for speed is meters per second. All right? So when you're talking about anything scientific, especially in this course, and you're talking about speed, you want to express it as meters per second. All right? So that's how you calculate speed, and then we went into how to graph speed. And we learned that on the horizontal axis, you label it as being time, and on the vertical axis, you label it as being distance. All right? You always do that. And the graphs for speed vary depending on the movement of the object. If an object is moving at a constant motion, then the graph is represented by a straight line. If the object is moving at a constant motion for a little bit and then stops, well, you get a flat line. If it starts moving again, the line becomes vertical. Now, if the object's moving back to the original point where it was at, the line goes down. So the distance would be decreasing as the object heads back to point A, to where it came from. So that's how you graph motion when we're talking about speed. And just for an example, I've graphed constant speed. So this graph represents constant speed because it's a straight line. And if you were to take any point on this graph, and you did the distance, whatever the number is for that, divided by whatever the corresponding number is for time, you would get the same answer. You would get such and such meters per second. For example, you may get 5 meters per second here when you did the distance divided by time, and then you would get 5 meters per second at this point, higher up on the graph, when you did the distance divided by time. It will always be the same with constant speed. Okay? You always get the same answer no matter what point you were at on the graph. So here's an example of constant speed. We also got into how to calculate acceleration. And we learned that acceleration is calculated as final speed minus initial speed divided by time. And what's that saying? Well, that's saying when you take the final speed minus the initial speed, you get the change in velocity. You get the change in speed because you're taking the final minus the initial. And that gives you the overall change in speed of the object from when it starts off, or from when it ends and when it starts off. So that's the change in speed. You can also say change in velocity if you're also mentioning direction. But change in speed or change in velocity goes on the top of the equation. And it's final velocity of the object minus the initial velocity of the object. Then right underneath there in the denominator, on the bottom of this equation, you write time. And that just expresses the amount of time it takes for that object to move from its final velocity, or from its initial velocity to its final velocity. So The graph for acceleration is labeled differently than it is for speed. Now, I mentioned that speed is expressed as a certain amount of meters per second. All right, a number could go above this line. It could be 10, it could be 20, but it's expressed as meters per second. Acceleration is different. Acceleration is expressed as meters per second, also known as meters per second squared. All right? So, look at this. We have meters per second over seconds. Well, what is meters per second? Meters per second is speed. It's the way you express speed. So, with acceleration, you really have speed over time. All right? And that's how you graph it. So take a look. That's how you label the graph. Let me see if I can find the right graph here. Here it is. All right. So you'll see that I have speed labeled as being on the vertical axis, and I have time on the horizontal axis. This is the graph for acceleration, right? This is at least how you label it. And on this graph, I'm displaying a positive acceleration. You can see the graph is going up. It has a positive slope. Now, you read these graphs differently than you do distance versus time graphs. Now, on the distance versus time graphs, I said that you could tell that the object is moving at a constant speed when you take the distance that corresponds to a certain second and you divide it. You will find the speed at that moment. All right? And if it's constant speed, it'll be the same for every little dot on this line. But it's different for acceleration. If you want to find acceleration and you're given a graph like this, you take the slope of the graph. All right? Now, I don't know how many of you are taking algebra right now, but slope is rise over run. All right? So to find, if you're just given a graph and you're asked to find the acceleration, you go up on the vertical axis, and then you run. So rise over run. And whatever point that you end up at, you will be given the acceleration. All right? So the acceleration is just it's the slope of the graph. That's how you find the acceleration. It's equal to the slope of the graph, the rise over the run of the graph. All right? And acceleration graphs are labeled with the vertical axis being speed in meters per second and time. As I said, acceleration is expressed as meters per second, aka speed over time. And look at this. Speed over time. All right? Meters per second over seconds. That is how you label in a graph for acceleration.